All right, time to do some Unit 2 test review. So the first thing I want to go over is AMU. Okay, remember atomical mass unit. There are two subatomic particles that have the AMU unit of 1, and that is protons and neutrons. So if I'm boron and I've got 5 protons and 6 neutrons in my nucleus, that means my AMU is going to be 11 because I have 11 particles in my nucleus, and protons and neutrons have an AMU of 1. Now, fun fact, we like to say that the electrons are weightless, but they aren't necessarily weightless. They're just really, really light. And so they're so light, in fact, that their mass is not actually calculated when we do the mass of atoms. So you'll learn a little bit more about that as you move on to higher level chemistry at in high school and beyond. So the next thing I want to go over is the law of conservation of mass. The law of conservation of mass states that mass or matter cannot be created nor destroyed. So that's really useful when you're looking at a chemical formula, and when you have your reactants and then you have your products, you need to be able to know as a chemistry student that the same number of molecules and atoms, let me back up, the same number of atoms in the reactants will be the same number of reactants in the product. They'll just be rearranged to form something new. So just so you know, when you see a test question that says something about the law of conservation of mass or matter, what they're really asking you is which one of these chemical formulas is balanced? Which one of these shows that no atoms got created or destroyed in the process, in the chemical process? So let's talk a little bit more about chemical formulas. Let's say we have H plus O2 reacts to create H. Nope. Let's do it like this. 2H plus O reacts to create H2O. So what you really need to see here is that we have our reactants in our products. And this arrow shows what yields. So this yields that. These reactants yield this product. These reactants go under some type of reaction to create a final product. That's really what's happening here. RYP. RYP. Reactants on the left, products on the right. Got to know that. And so what you can also do is you can T-chart, and this is what I recommend before answering any questions ever. Just do elements, atoms. What elements do I have here? I have H and I have O for a total of 2 elements. I have 2 H's and I have 1 O for a total of 3 atoms. Then you come over to this side and you will T-chart this side. So I have H and I have O for a total of 2 elements. I have 2 H's, 1 O for a total of 3 atoms. And then what you do is you'll go down and you'll verify that everything is balanced and everything's correct. So here I have 2H, 2H. I've got 1 O, 1 O. I've got 2 and 3. I've got 2 and 3. This is a balanced equation. And that's how you T-chart a formula with your reactants and your products. Okay. Let's move on here. Now let's talk about chemical reactions. So now that we've got our final product, there's evidence to show how it got there. And there's not a whole lot of evidence. There's just a few things you need to remember. And that's please excuse coughs, burps, sneezes, or chunks. So the P stands for precipitate. This is when you mix two liquids together and you get a solid. Okay? Two liquids together, you get a solid. E is for endo/exothermic. This is if you mix two chemicals together and just based on the mixing, the temperature increases or decreases. Not that there was fire added, not that it was put in ice. That's not evidence of chemical change. The fact that it changes on its own simply because you mix the chemicals, that is evidence of chemical change. That is an endo or exothermic reaction. Endo means heat is absorbed. Exo means heat is released. Exo is a campfire. You put your hands nearby, you can feel that heat being released. That's an exothermic reaction. So C, let's go with color change. Now I caution you here because if they talk about a red liquid, that doesn't mean the color has changed. You have to actually see evidence that it was blue and it went to clear, or it was clear and it went to red, or it was clear and it went to blue, or it was clear and it went to black. Pay attention. They may not say that. There may be a diagram or a visual that shows that. So you have to break down the question to make sure that you understand that there has been a change in the color of the chemicals. And if there is, that's all the evidence you need to know that a chemical reaction has occurred and a new substance has formed. B, bubbles. Do you see any form of bubbles? If you've seen bubbles, chemical reaction. Smells. If there's an odor, chemical reaction has occurred. A lot of times in the Northeast, there's acid rain, and that acid rain will hit on a building, and there will be a smell in the air. And that smell is that a chemical reaction has occurred. Those buildings are changing, and they cannot be changed back. So O is oxidation. Like if you leave your bike outside too long and it starts to rust, it can't go turn back to a brand new bike. Nope, it's rusty now. That's rust. Oxidation is rusting. And evidence of chemical change. Last is combustion. Fireworks going off, bomb going off, those types of things. Combustion. An explosion. So that is your pieces of evidence that a new substance has formed. Okay? This is evidence that your chemical formula, your chemical reaction has happened, that your reactants now turned to a new product, and this is the evidence to show that it went to that product. Maybe that will help you understand. Okay, done with that. Moving on. Let's go with, what does chemical reactions show? Chemical reactions will show you simply the number of atoms in a molecule. How many atoms or molecules are in that chemical reaction. That's all it shows. It can't show you a visual representation. You don't know what it looks like. You don't have any other information. You just know it's like a recipe, if you will. It tells you what it is and how much, what's in there and how much of it. And a chemical formula pretty much identifies all of the elements, molecules, and compounds that are within that formula. So if you go back to that formula for H2O, that's what that shows you. It identifies the elements, H and O, shows you the atoms, the H and O, the elements, the atoms, same difference. The molecules, so there was so you had one molecule of H2. So there's that. Remember the definition of a molecule. A molecule is two or more atoms. And then compounds. again, 2 or more elements. And then, you know, and you can see how many of those are within that formula. So it's just kind of like recipes. That's how you kind of want to look at it. Again, though, the best evidence that a chemical reaction has occurred is that a new substance is formed. And you have those pieces of evidence that I showed you, the please excuse, coughs, burps, sneezes, or chunks, that'll help you identify that there is, in fact, a new substance there. And then the last thing that you need, well, there's two things. Make sure that you understand how to T-chart, and you're going to need to do a lot of T-charting for this, so have, you know, a piece of paper handy. I would recommend, again, doing the questions on a test. And then what I'll do for this next upcoming unit test is I'll make sure that the answer choices, the questions are not mixed around, that you can easily transfer your answers from your paper test over to Eduphoria. And then the last thing you'll want to know is the difference between molecules, compounds, and elements. This is an element, 1 atom of hydrogen. This is a molecule because you have 2 atoms of hydrogen. This is not a compound because it's only one element. This is now a compound and a molecule. Because remember, all compounds are molecules, right? Because just by the definition alone, as long as you have 2 atoms, you have a molecule. And if you have H and you have O, you have 2 elements, which gives you 2 atoms, which gives you a compound and a molecule, so it qualifies for both. That's all you need for this upcoming Unit 2 test. Good luck, guys. We'll see you in class.